Today's topic is conjunctive normal form and disjunctive normal form. First, we know that what is conjunctive normal form or CNF. A compound proposition P is said to be conjunctive normal form or CNF of R simple propositions P1, P2 up to PR if the expression P can be expressed as P is equals to P1 conjunction of P2 conjunction of up to PR, where each PI is the disjunction of a finite number of the simple propositions of each of P1, P2 up to PR or their negations, and Pi not equals to Pj for all distinct I and j. For example, P equals to negation of P1, disjunction of P2, disjunction of P3, or conjunction of negation of P1, disjunction negation of P2, disjunction negation of P3, conjunction of P1, disjunction of P2, disjunction of P3 is a CNF. Or P is equals to P disjunction of negation of P conjunction of Q is not a CNF. Now, what is DNF? DNF means disjunctive normal form. A compound proposition P is said to be a disjunctive normal form or DNF of R simple propositions P1, P2 up to PR if the expression P can be expressed as P equals to P1 disjunction of P2 disjunction of up to PR, where each PI is conjunction of some of the simple propositions or their negations without any repetition, and no pi is contained in any of pj where j not equals to I. For example, p is equals to p conjunction of negation of r, disjunction of negation of q, conjunction of p, conjunction of r, disjunction, negation of p, conjunction of negation of q is a DNF, because here p conjunction negation of r is a conjunction of p and negation of r, and negation of q conjunction p conjunction of r is a conjunction of negation of q, p and r, and so on. Another example, p conjunction negation of r, disjunction of p conjunction negation of q, negation of conjunction of r, disjunction negation of r, conjunction p conjunction q is not a DNF, since p1 is equals to p conjunction negation of r is contained in negation of r conjunction p conjunction q, which is equals to p conjunction of negation of r conjunction of q, that is p conjunction negation of r conjunction q. This one is repeated into here, so this is not a DNF. Now we saw that some CNF and DNF here. Find the CNF of the following statement. Okay, here the statement is negation of p disjunction q implies and implied that p conjunction of q. Okay, if we find here the truth table of this statement, so this will be p q, true, false, true, false, true, true, false, false. Next, p disjunction q. This one, p disjunction q is at least p and at least any one of p and q is true, then it is true. Otherwise, it is false. P conjunction q. If only p and q both are true, then it is true. Otherwise, false. Okay. Next, negation of P disjunction Q. That means negation of this one. So this is false, 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 and true. Now say it is capital A. That means now we have to find out A implies that P conjunction Q. Now for this statement, if both the statement is true, then it is true, or both the statement is false, then it is false. Otherwise all are if both the statement true, then it is true, and both the statement false, then it is true. Otherwise it is false. That means this one is false, this one is true because both the statement is true. Both the statement is false. This one is also true, so as both the statement is false, this is false. Now for this true and for this true, we find the CNF here. This will comes from here. So if P is true, Q is false, then it is true, and P is false, Q is true, then it is true. If we for this statement, if we write here, that is for this, if we write here P and P and F, so disjunction of Q, then as this for true we write P, that means this is false, that means we write here negation of P, disjunction, here we false position we write Q, so this is the negation of Q. Okay, so this is the CNF here. Clear? Next we find the DNF. For this statement. Okay. Similarly, P, Q, so it is R, true, false, true, false, true, false, true, false. True, true, false, false, true, true, false, false. True, 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 false, 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 false. Now we have to find out P conjunction R. P conjunction R, if both are true, then it is true, otherwise false. This one also true, so it is true. This is false, then all are false here. Okay, then negation of Q. Negation of Q means this is false, false, true, true, false, false, true, true. Negation of Q, disjunction of R. If anyone is true, then it is true. Sorry, this is true, this is false. True, 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 false, true, true. Next we find this implies and implied that negation of Q, disjunction of R. For this and this. If both are true, then it is true, and if both false, then it is false. It is also true, both false, it is true. This is false, this is false, this is true, this is false, and this is also false. So here 4 position we get the true value. Okay, now we have here the disjunction. That means DNF is DNF means what is DNF here? That means conjunction is disjunction is the disjunction of some proposition. Okay, and conjunction of the each proposition. So here this is the true position. That means for this true we find here, that means all are true here. So if we write here, this will be P conjunction Q conjunction of R. Okay, disjunction of, then this will be P conjunction Q conjunction negation of R. Okay, disjunction of, this is P conjunction negation of Q conjunction R, and lastly this is conjunction negation of P conjunction Q conjunction negation of R. Okay, so this is our DNF. Now we have to know that what is argument. Argument is deduction of a proposition Q from the set of proposition P1, P2 up to Pn, which is compound or simple, is called argument, or symbolically we write P1, P2 up to Pn argument of Q. Here P1, P2 up to Pn are called premises and Q is called conclusion. Okay, this is our argument. Next, valid argument. An argument P1, P2 up to Pn, this one is Q, is called valid argument if P1 conjunction of P2 conjunction of up to Pn tends to Q. That means if this then Q is a tautology. What is tautology? Tautology means whenever we find out the truth table of this statement, all the entry on the last column is true value. Okay, then if it is a tautology, then it is valid argument, otherwise it is invalid argument. So an argument which is not a tautology is called invalid argument. For example, say we have to find out the truth table of the expression, say P1 conjunction of P2 tends to Q. If we find the truth table of this expression, if all the values are true, then this expression is a valid argument. Okay, then if we find it, where P2 is P1 P tends to P conjunction of Q. Okay, and P1 is a small p. So P1 is small p, and this is Q, and P2 is equals to small p conjunction of Q, small p tends to Q, small p tends to Q, and P1 conjunction of P2, then P1 conjunction of P2 tends to Q. True, false, true, false. True, true, false, false. Then P tends to Q. That means this is true, this is false, this true, this true. So capital P1 conjunction of capital P2. If all is true, then it is true, otherwise it is false. Then this one tends to small q. This is true, false, false, so it is true, false, true, so it is true, false, false, it is true. So all this expression in the last column is true. That means it is a tautology. So here P1 conjunction of P2 tends to Q is a tautology. Okay, that means P1 P2 is a statement, and the total argument, this one, is a valid argument. Okay, another example. Find whether the argument P tends to negation of Q, R tends to Q, R negation of P is valid or not. So this argument is valid if the proposition P tends to negation of Q, conjunction of R tends to Q, conjunction of R, this will tends to negation of P is a tautology. Okay, now we find here the truth table also. True, false, true, false, true, false, true, false. As there is a 3 combination, so we get 8 outcomes. True, true, false, false, true, true, false, false. And this is 4 true and 4 false. Okay, then we find out negation of Q. Negation of Q means false, false, true, true, false, false, true, true. Then P tends to negation of Q. This is true, sorry, this is false. True, false, this is false, this is also false, this is true, 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 and this is true. Then R tends to Q. This true, this true, this is false, this is true, this is true, true, false, true. Say it is A and it is B. That means A conjunction B conjunction of R. This and this. All this conjunction, that means this is false. This is also false. This is also false. This is false. This is only true. This is false. This is false. And this is also false. Next, another is negation of P. False, 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 true, 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 true. Now we find A conjunction B conjunctions R. This will tends to negation of P. Okay. Conjunction tends to, there is if and then. This will seems this is false only when the first is true and second is false. As here both are false, so it is true. Both false position, that means all are true. Both true, that is also true. This is also true, false, true position, this is true, this is also true. So all the entry in the last column, it is true. That means it is a tautology. So the statement or proposition is a tautology. That means the argument is valid. Now another example. Say express the following argument symbolically and test whether this is a valid argument. The statement is if row B solve this problem, then he scores 90. And another statement is row B scores 90. And our conclusion is row B solve this problem. Okay. Now, solution. Let P is row B solve this problem. Okay. And Q is row B scores 90. That means the first statement is, say, capital P. This is equivalent to small p tends to Q. Okay. And the argument can be written as symbolically. Argument is capital P small q. This will implies that small p. Okay. So this is our argument, and we have to show that this is valid or not. Okay. If it is valid, then it will be a tautology. So let us see the truth table of this statement. That means we have to find out capital P. Capital P, small p tends to Q. Okay, if it is a valid argument, then we have to show that that means capital P conjunction of small q tends to small p is a tautology. Okay, we have to show it. So here we have to find out capital P conjunction of small q, and then capital P conjunction of small q tends to small p. So it is true, false, true, false, true,